A small rigid spherical ball of mass m is dropped in a long vertical tube containing glycerine. The velocity of the ball becomes constant after some time. If the density of glycerine is half of the density of the ball, then the viscous force acting on the ball will be. See, whenever something falls, let us assume something falls, right, into a liquid, then what will happen when an object fall into the liquid, right? In that case, the buoyant force acts vertically upward, right? And also the viscous force acts vertically upward. So two forces acts vertically upward. One is the buoyant force and another is the viscous force, and one force acts downward, and that is mg. Now if the object move downward with constant velocity, it means, see, the velocity is constant, it means that the net force acting on the object is 0. It means that mg is balanced by buoyant force and the viscous force. So how we can write the equation? We can write like this: mg is equals to viscous force plus buoyant force, because these two forces are balanced by right, by mg. Now we can rewrite this: mg is equals to F viscous plus, now buoyant force is given by rho Vg, right, that is the density of the liquid into volume of the object inside into G, right? But in the question it is given that the density of glycerine is half the density of the ball. Okay, so let us assume the density of the ball is rho, then the density of the glycerine will be rho by 2, right? And mg, right, mg, m is mass, so mass can be written as density into volume. This is the density of the ball and the volume of the ball. So I can write it as rho Vg is equals to Fv plus rho by 2 Vg. Now what we will do, we will make this as a subject, viscous force. So F viscous is equals to rho Vg minus rho by 2 Vg. Now if you solve this, right, you will get rho Vg by 2. But here rho V is the mass of the object. So mg is equals to rho Vg. Okay, density into volume into G, and that is equals to mg. So I can write here mg by 2. That is the viscous force acting is mg by 2. Hence the correct answer is option 2.